We're on to question 4A here on the 2020 paper, I believe. And we're given just another standard question. I might just call this tan x equals minus 1 over root 3, where x equals theta over 2. Now it's in radian form, so we're going to go for ASTC here. A is 0 to 90, S is 90 to 180, T is 80 to 270, C is 270 to 360. And we're going to try and solve this. Tan is clearly negative. Okay. And if you want, for this type of question, 2 pi is actually 360 degrees. So 4 pi is 720 degrees. What we could do is we could do the answer in terms of degrees, and then at the very end, we could change it into radians. Might be a good idea. Just use the conversion where pi equals 180 because 2 pi equals 360. Tan is negative. That means we're using S and C. S is 180 minus your reference angle, and C is 360 minus your reference angle. Reference angle is obtained by getting the positive inverse. Ignore the sign and just inverse it. Shift tan inverse 1 over root 3. Okay, and what we're going to get is 30 degrees. Put your R equals 30 and you get 150 and 330. Is that okay? 150 and 330. Okay, that's what we're looking at right there. Now, the only problem is we have to take into consideration that it's not one circle, it's 2 circles. So we have to actually add on 360 to both of these because it has to go all the way up to 320. So we have to add on another 360 onto this. So 150 plus 360 is going to get me 510, and the other one's going to be 690. Now, at this stage, I realized that I'm meant to be doing this in terms of radians. So I'm just going to divide everything by 180 and slap on a pi, because 1 degree is pi divided by 180. So I'm just going to do 150 pi divided by 180, 330 divided by 180 pi, 510 pi divided by 180, and finally 690 divided by 180. And I'm just going to put all these into the calculator. The first one's going to be 56 pi. Second one's going to be 11 pi over 6. Third one is going to be 17 pi over 6. It looks like pi, mind you, but it's 17. 17 pi over 6. And the last one is going to be 690 divided by 180. 23 pi over 6. There we go. There's my answers. Once again, just going to check them on the old yeah. It's asked me for the 2 values. Oh, this makes things even worse. See, these are the answers for x, and I don't want the answers for x. I want the answers for theta over 2. So this is going to be fun. Now we're going to do theta over 2 equals the following. So to get theta on its own, I need to cross multiply up to 2. So that will be 10 pi over 6. This one will be 22 pi over 6. This one will be 34 pi over 6. And this one will be, 46 pi over 6. This automatically rules out these 2 answers here because they are clearly above the 4 pi mark. 34 divided by 6 is greater than 4. So this leaves these 2 answers here, which are 5 pi over 3 and 11 pi over 3. I actually would have forgot that had I not checked the marking scheme and not rechecked the start of the question that we were not looking for x, we were looking for theta over 2. So just shows you how you can sort of go off thinking you're correct when you aren't. Okay. Now, part B. It's going to be fun. Diagram shows OAB, a sector of a circle of radius 7 and center O. The BOA is 1.2 radians. The area of the shade. So they're giving us the area of the shaded region. Okay? And they're asking us to find BC. The goal of the question is to find BC. Now, here's what I'm thinking. What I'm thinking is we get the area of the full pizza slice. So if you look at the full pizza slice, that's the area I'm getting. I have to use area equals a half r squared theta because it's in radian form. So that's what I'm looking at here. Thinking about using that. I'm not quite fully sure just yet if I could use that. I'm thinking of the area of a. I'm also thinking of the area of a triangle formula. The small triangle here, but that really isn't going to help me here at the moment. I could probably, yeah, I'm going to get the area of the full thing, the full pizza slice, okay? And that's going to be a half 7 squared 1.2. Okay, that's what I'm thinking first of all. Half 7 squared, so 0.5, 7 squared, and then 1.2. Okay, and that is going to get me 29.4. Now I'm going to take away 21 of it. 21 of it is this region here. So I'm going to minus 21. And that's going to leave me with 8.4. So that means that this triangle here is actually 8.4. Now, what I'm going to do is going to use the area of a triangle formula. So this red line multiplied by this green line. So a half AB sine C equals 8.4 because that's the area of the triangle. So it's going to be a half, we'll call this green line X. So it's going to be half 7 times X. It's going to be in radians, so it's going to be sine 1.2 equals 8.4. I'm going to put in the parts that don't have a letter in it. So I'm going to enter in a half of 7 sine 1.2, once again in radian form. So you're going to shift setup, going to go to angle unit, going to go to radian. I'm going to go 0.5 times 7. And I'm going to do sine 1.2. And I'm going to get 3.2621. So 3.2621. X equals 8.4. Then I'm going to divide that into 8.4. I'm going to do 8.4 divided by answer. I'm going to get 2.575 for X. Now what does it want? Correct to 1 decimal place. Ouch. Still going to be 2.6 no matter what way around it that anyway. So it's going to be 2.6, okay? Now, to get the length of B to C is just going to be this purple line here. And it's going to be 7 take away your 2.6. So 7 take away 2.6. And you get 4.4. And that there centimeters is going to be the length of that guy.